All right, I'll be solving this question in this video. This question is taken from horizontal projectile. I think some times ago I took time to do some analysis on the motion of a body that is projected horizontally, maybe from the top of a platform or from the top of a cliff or from the top of a high tower. Now, this question says a stone is projected horizontally from the top of a tower 50 meters high with an initial velocity of 30, of course, that is the horizontal velocity, 30 meters per second. Take g as 10 meters per second squared. We have to calculate the resultant velocity of this stone after 1.5 seconds. So I'll be doing justice to this question from this other board here. A stone is projected. Look at the question very clearly. Okay, let me just quickly do a sketch of this question. Okay, let's see. This is this tower from which the stone is projected with an initial speed of 30 meters per second. Of course, let's say this stone, of course, is going to follow this path. The path taken is a parabola, of course, until when it hits the ground at this point. Let's call this point Q. This point is the same level as the foot of the tower. Let's call that point F, the foot of the tower. The height of the tower is 50 meters, okay? It is given. The stone is projected from, with an initial velocity of 30 meters per second from the height of a tower that is 50 meters. Now we have to find the distance. Now we have to calculate the resultant velocity of this stone after 1.5 seconds. That is, we're looking for the resultant velocity. Resultant velocity has to do with the sum of two different velocities, the vector sum of two velocity. Mind you, this kind of motion is two-dimensional. As the body moves horizontally, it's also covering some vertical distances. So it's a two-dimensional motion. So let's say at 1.5 seconds later, the particle is at this point P. So we want to find the two velocities or the resultant velocity. That's the Vx component and the Vy component. These two components will be found before we now find the resultant velocity which acts along this line tangent at point B. Let's call that V, which is my resultant velocity. So my Vx is what? Okay, my Vx is 30 meters per second and it remains constant. Remember, in this case, the stone does not accelerate in the horizontal direction. Of course, it's not falling under gravity in that sense. Gravity doesn't affect the motion of a body in this horizontal direction. So vertically speaking, my Vy is given as g times t. I've done this analysis before, and if you have not seen that, I'd like you to go and check those videos where I took time to analyze the motion of a body falling or moving horizontally. So g is 10. That gives me 10 times 1.5. That gives me 15 meters per second. So the resultant velocity, therefore, is a vector sum that is using Pythagoras. Of course, you can check that we can make this up to a right angle triangle. Okay, and this is my Vy, and this is my Vx here. My Vx act along this line. My Vy that results in a right angle triangle. So that gives me 30 squared plus 15 squared. Okay, the sum of these squares and their square root. This is 900 plus 225. That gives me 1125. So taking the square root of that will give me my final answer as 33.5 meters per second. So that gives the resultant velocity of this stone after 1.5 seconds. So let's take the second question. The second question says we are to calculate also the distance from the foot of the tower where the stone hits the ground. That is after the stone must have hit the ground. What's the distance where the stone hits the ground from the foot of the tower? Of course, we call that the range of the projectile. So how do we find the range? The range has to do with the horizontal distance covered by the stone. So we have range is equal to speed times time. Of course, distance is speed times time. Since range has to do the horizontal parameter, so this becomes my 30 times the time taken to reach this point. I need to get that, I need to find that because the time taken to get to point Q is different from the time taken to fall to point P. So how do I get that time? I need to get that time from the first equation. I have the height of the tower is half gt squared. Okay, so the height of the tower is 50. That gives me half times 10 times t squared. That gives me a 5t squared is equal to 50. Dividing both sides by 5, I have t squared is equal to 10 and t equals to the square root of 10 That gives me 3.2 roughly seconds. Okay, so come here to find the range. The range of the projectile, the range from the that's measured from where the stone hits the ground to the foot of the tower is u times t, which is 30 times 3.2. That gives me 30 times 3.2. I have my final answer as 96 meters. So that is approximately the range of the projectile. And the next question says calculate the displacement of the stone. The displacement of the stone, of course, displacement is just this line that connects the top of the tower to the point Q. The length of this line is the displacement, okay? Because for a while ago, the stone was at this point, the top of the tower. A moment later, the stone is at this point. So this straight line gives a displacement. So I can call that my S. The displacement of the stone S is equal to the vector sum. I can call that S squared because this has the shape of a right angle triangle. By Pythagoras, that gives me the vector sum of the range squared plus the h square, that is the height of the tower, okay? That gives me displacement is equal to the square root of the sum of the squares of the range and the height of the tower, which results in this, I got this my 96 squared plus 50 squared, okay? When I evaluate this now, I'm going to have 96 squared plus 50 squared. I hope you have your calculator there, 50 squared. So they can also join me in computing and finding answers to this solution. So that gives me this, and that is 11716. So that the displacement is the square root of my answer, which gives me 108.2 meters. So that gives the displacement of the stone from where it was projected. Now the last question says we should find the velocity of the stone as it hits the ground. What is the velocity? With what velocity will the stone hit the ground? Now it takes 3.2 seconds for the stone to hit the ground. That is from the point it was projected, point O, to when it hits the ground at point Q. Alright, so which means the velocity, vertical velocity Vy, before the stone hits the ground at point Q is like a stone that falls from rest along this line. So that gives me gt. The g is 10, the t is 3.2. So the vertical velocity at point Q is 32 meters per second. Okay, that's the vertical velocity. The horizontal velocity of the stone Vx remains 30 meters per second. Recall that horizontally, looking at the horizontal aspect of the motion, the body does not accelerate in that direction. The horizontal speed remains constant throughout the fall. So that gives me the resultant velocity just before the stone hits the ground as the square root of 30 squared, that is Vx squared, plus 32 squared, that is Vy squared. So once again, we go back to our calculator, 30 squared plus 32 squared give me this 19, that's V gives me square root of 1924. So taking the square root of that gives me a final answer as 43.9 approximately meters per second. That gives the horizontal, or sorry, that gives the resultant velocity of the stone as it hits the ground. So then it can ask you to find the total energy of the stone while it hits the ground, and that is will be equal to the kinetic energy, the loss of Ke. What's the kinetic energy of the stone just before it strikes the ground, which gives the total energy, that gives half m v squared. Now this v becomes the resultant velocity of the stone, and that gives me half times the mass of the stone must be given. Let's say the mass of the stone is 0.5 kg or 50 grams, 0.05 kg, times the speed of the stone, 43.9 squared. I mean, that is the resultant velocity we got here just before the stone strikes the ground. So the total energy of the stone as it hits the ground is half times 0.05 multiplied by 49 was multiplied by 43.9 square. I have that before. So when I evaluate this, I'm going to have that times 0.05 times 0.2, which is half, 0.5, which is half. That gives me 1.09. So the K of the stone becomes 1.096 joule, which is approximately 1.1 joule. So that gives the kinetic energy of this stone, which is also the total energy of the stone before the stone strikes the ground. And that is how it is. And if you ask to find or draw the graph to show the variation of the stone's vertical velocity Vy against time. Vy increases from 0 to a maximum value after 3.2 seconds, which is total time taken to land to hit point Q. The velocity of the stone, that's a Vy before it strikes the ground, was 32 meters per second. Okay, that's the Vy component with time. Then Vx vary with time. Since Vx is constant, so it remains 30 meters per second with time. That is independent of time. So this is how these two quantities vary with time. Okay, the next video we'll look at more questions on this.